From the beautiful North Studios of Way Happy, this is Mr. Meyer and 29 Absolute Value. So let's talk about absolute value. And really what we're talking about here is graphing transformations. First thing I want you to know about absolute value is that the graph is a V-shaped graph, right? So absolute value, when you go to graph it, it looks like this. That's what it looks like, a nice V-shaped graph. Now, how do I know that? Because if you make up some x's and you plot them, so let's say that our x's are -2, -1, 0, 1, and 2. When you plot them, you plug in -2, you take the absolute value, you get 2. Plug in -1, you get 1. Plug in 0, you get 0. Plug in 1, you get 1. Plug in 2, you get 2. And if you plot those points, you get a beautiful V shape. Now, past that V shape, we're going to talk about the transformations. How do you slide this graph around? How do I make an absolute value graph? How do I make it go up or down or left or right or flip it over the x-axis or the y-axis? Or, how do I make it steeper or stuff like that? And that's what this is all about. The big trick to knowing about what this is when you do horizontal transformations, you will have to do the opposite. Something weird is going on whenever you're doing a horizontal. It's going to be happening to just the x and the x alone. And when you do a vertical, it's going to be normal, everything's fine, and you do it to the whole function. So that's the big key. So let me show you what I want to talk about here in this first example. So in example 1, I want to take an absolute value function and I want to move it 5 units down. So if I want to move it 5 units down, that's in the vertical direction, and that's normal. So all you do is you take the graph, you take the function, whatever it is, in this case, this function, and you do to that entire function, you just do what you would think. 5 units down is just -5. So if you're going to move up or down, you're going to just add or subtract whatever number it is, and that will move your graph up or down. That's it. Finished, right? So for those of you wondering like, hey, well, what would the graph look like? Well, now it's going to go up 5, 1, 2, 3, 4, 5, and I make a V shape. And there you have it. All right, what about this other one? What about 1 unit left? Now that's in the horizontal direction because left and right is horizontal. So it's a lot scarier because you have to do the opposite of what we thought we'd have to do. Instead of adding 1, we'll subtract 1. And it only happens to the x, not the whole function. So here's your function, right? And then what I got to do is go, oh no, to the x is the only thing I want to do it to, not the whole absolute value, because absolute value is the function. I have to then do the opposite. So 1 unit left, instead of going -1, is going to be +1. And that will move the graph left 1, and it'll make an absolute value there. And so there's the weird part. Anything that goes in a horizontal direction is left and right. It's going to be the opposite. And then you just add it to just the x. That'll slide the graph left, slide it right. Anything added to the whole function, added to the absolute value bars, is going to move it up and it's going to move it down. This is a concept that we're going to do a ton of, right? This concept is going to go for every graph. And in pre-calculus, we make you learn 12 different graphs, and this will hold true for all 12 graphs. So if you can start to get it, make sense of it now, and probably won't be the first time, but we're going to do it a lot, and hopefully by the end you'll be very comfortable. So again, left and right, you do the opposite, and up and down, you just do exactly what you would think. So now look, if I look at this next equation, you can read what the book clipping I have there. But if you read this next thing right here, it says that I want the vertex at -1, -3. So -1, I want it right here, and then I want an absolute value graph. Well, look at which way it's shifted. It's shifted left 1 and down 3. So if I know that left 1 is a horizontal shift, happens to only the x value, then I can go, all right, I'm going to take the absolute value, and I'm going to go x + 1. That caused the left 1 shift because I did the opposite of what you would think. You would think left would move it negative. So I do the opposite, which is +1, and I do it to just the x. Now the down 3, that's a vertical shift. And a vertical shift is you do exactly what you would think. There's nothing fancy. And do it to the whole function. So do it to this whole thing right here, right? That whole thing is going to just get a down 3 shift. So in our case, That's just going to be a -3. And there is your equation. That is the equation of your graph. And I already graphed it. I did it first. But there's your equation of an absolute value graph that is left 1 and down 3. Crazy, right? All right. Hold on to your hats. But I'll ask you a question and we'll be right back. All right. Nice work. Now, here's the next part too. We can also stretch these graphs and compress these graphs and flip them. And those are all multipliers. So if you want to do what we call an x-axis reflection, right? If you want to do an x-axis reflection, then all you're going to do is take your equation and you're going to put a negative out front. So if you just put a negative out in front of the whole thing, that's going to cause an x-axis reflection. If you want a y-axis, then all you're going to do is do an opposite on the x. So again, those two things you will have to worry about on which reflection it is. Also, if you are going to stretch, so let's do a vertical stretch. If I'm going to do a vertical stretch of a graph, then I will multiply it by a number bigger than 1. I will multiply the graph by whatever, just out front, something bigger than 1. If I want to do a vertical compression, then all I'm going to do is multiply the graph by something smaller than 1. And that will stretch the graph vertically. It'll make it taller, right? And it will also compress it vertically. Now, what about horizontally? Remember, horizontally is always the weird one. So a horizontal stretch, you would say, oh, I know, stretch. If I was going to do a horizontal stretch, I would do it to just the x, right? So I would do it to the x. But remember that horizontal is always opposite. So a stretch is actually a small number that will cause a horizontal stretch, where a horizontal compression, that would be a big number to just the x, because darn it, everything to the x is opposites. So there you go. You got your reflections and you got your horizontal and vertical stretches and compressions. All right, now let's go over to 3a and b and c and see how easy this can actually be applied to the graphs. So here you go with 3a. It says, look at this graph and I want you to reflect it across the y-axis. So again, look over here, and on the y-axis, we're just going to change the sign on the x. Now, how do we do that? We take everything that is inside the absolute value bars. We take all that stuff and we just put a negative out front of it. And that's it. That causes the y-axis reflection. You could make it look a little prettier, I guess, like -x plus 2. But you have now reflected the graph across the y-axis. And that, what the heck? And that will be you reflecting it over there. And it also brings up a good point that I want to mention is, if you look right here, some kids might see that +2. By the way, did you know which way this was shifted? Look at the original problem back up here real quick, and then I'll talk about that. It looks like it's right 2, because remember, you do the opposite of the inside. When it's inside with the horizontal with the x, you do the opposite. And when it's on the outside, that's a up 3. So it's a right 2, up 3 shift. Well, if you were careless and you looked at my final answer, you might think that my x plus 2 would cause a left shift. You'd be like, oh, that's a left shift of 2, but it's not, because it's not happening to the x, it's happening to -x. So that's why you'd have to factor a negative out, and then you'd be up here, and then you'd be like, oh, it is a right 2 shift. So remember that transformations always happen to the x, not -x, not 2x, not 5x, right? They always happen to just the x. All right, part B. How do I stretch a graph vertically by a factor of 2? Well, a vertical stretch is going to be just put that number out front, multiply it to everybody. So you take your graph that you had, and you're just going to multiply it all by whatever factor they want. If it's vertical, again, horizontal would have been on the inside. And so there it is. Now I could clean that up again too. I could make this 2 absolute value of x minus 2. That's a good answer. And that would be, again, your vertical stretch by a factor of 2. And you'll notice that your y-intercept is changed, but that makes sense because we stretched it twice as tall. So now instead of being down 1, it's actually down 2. All right, what about our last one? Our compress horizontally by a factor of 1/2. Remember, horizontally has to be inside with the x. So, and it's inside, that means we're going to do the opposite. So if I'm going to compress you horizontally by a factor of a half, then what I'm going to do is I'm going to actually multiply you by 2 because it's the opposite. So I went to the insides, took everything that was inside, and I multiplied it by 2 because that will horizontally compress it by a half, right? And so again, you could definitely clean that up. You could leave it like this. That looks beautiful. Or you could write it as absolute value of 2x plus 4 minus 1. And again, some kids might not notice. They would look at this part right here and they would say, oh, that's a left 4 shift. Not true, because it's not happening to the x, it's happening to 2x. So you'd have to factor the 2 out and then tell me, oh, I'm sorry, it's a left 2 shift. All right? There's a lot of little tricks. We're going to get a lot of practice in class. So I want you to have a good day, stay happy, and I'll see you tomorrow.